Hey everyone, welcome to a new video. Mr. Smith here. Let's get you started with a joke. So, what is the best cereal to eat late in the fourth quarter? Cinnamon Toast Crunch Time, of course. It's crunch time late in the fourth quarter. You need some Cinnamon Toast Crunch Time. So, hopefully you don't think I'm incredibly stupid because of my jokes. Hopefully they give you a little bit of a laugh. So, let's get rolling into this video. We are beginning to talk about factoring in this video, which is actually going to take us through the end of this week as well as into next week. So we're going to be talking about this for a little bit. I'll give you a little bit of intro for what I mean by factoring. Let's just think about what we know how to do. Last week we talked about multiplying two polynomials. If I asked you to multiply this, you would have to double distribute. You would distribute both pieces of the first polynomial into the second. X times x is x squared. 5 times x is plus 5x. 5 times x is, again, oops, sorry, messed that up. X times x is x squared. X times negative 2, I just skipped a step. X times negative 2 is minus 2x. 5 times x is plus 5x. And 5 times negative 2 is negative 10. Okay, so that's looking better. And now we have some like terms in the middle that we can combine. Negative 2x plus 5x. That's going to be x squared plus 3x minus 10. And we're done. Okay. So now the question that I'm asking you is, what if we wanted to undo this process? What if I wanted to start here and go backwards? If I wanted to start here and go backwards to the beginning of our problem. So what would we need to do in order to start at a polynomial that's already been multiplied out and go backwards into a polynomial that has been factored? Notice this is two factors, okay? Two things that are being multiplied together. This is a process called factoring. All right, what it is the process of taking a polynomial. You're going to start with a polynomial and rewrite it as the product of multiple polynomials. Okay, so you're going to break it up into multiple factors or multiple things that are being multiplied together. Okay, so this is the process that we're going to be looking at for about the next week. Today we just have to look at one particular part of this. It's called factoring by grouping, and that's the main thing for this video. If you have a polynomial with 4 parts, okay, notice how this polynomial has 4 terms. We can do something called factoring by grouping, and we're going to have to use this skill later on when we factor more complicated polynomials. We're just going to focus on it in particular in this video. So let's say I want to factor this polynomial by grouping. Here's what I'm going to do. There's a couple steps that I need to work my way through. First, I'm going to break up this polynomial into 2 groups. I'm going to split it in half. The first half has the first 2 terms, the second half has the second 2 terms. I just break it up by writing parentheses around them. Okay. Then what I'm going to do is I'm going to look at the first group. I'm going to ignore the 2x plus 6. I'm just going to look at the first part of my grouping. And I'm going to see if I can factor out a GCF out of that. Remember, GCF from the last video is just something that I can divide from both terms of this first part. So I got x cubed plus 3x squared. Well, there's no the coefficient of this first term is 1, so there's not a number that I can factor out of both of them. But there is a variable. They both have at least x squared. This one's got x cubed, this one's got x squared. So I could factor an x squared out of both of these guys. So I'm going to go ahead and do that. Let's say I factor out an x squared from that first piece. Now I'm dividing both of these by x squared. X cubed divided by x squared, that's just x. And 3x squared divided by x squared, well, that's 3. Okay, so I've taken an x squared out of my first polynomial. Now I'm going to ignore that, and I'm going to go look at my second piece. And I'm going to do the same thing. Is there something that I can factor out, a GCF, that I can factor out of both of these terms? Well, they don't both have a variable, so I know I can't take out an x, but they do both have a number that I could factor out. I could divide this by 2. I could also divide this by 2. So the GCF that I could take out of there is 2. So I'm going to factor out a 2. And again, I'm going to do exactly what I did right here, except I'm going to do it with this piece. I'm going to factor out a 2, and it's going to be a positive 2. Okay, so I want to write plus 2, and I'm factoring out, I factor a 2 out from both things, so I'm going to divide both parts by 2. 2x divided by 2 is x, and 6 divided by 2 is plus 3. Okay, and remember, if these have negative signs, then we're going to have to show that down here if we're factoring out a positive. All right, so we're not completely done yet. Remember, I'm trying to get my answer to look like, I'm trying to get my answer to, oh my gosh, sorry guys, trying to get my answer to look like that. Two things that are being multiplied together. So we're almost there, but we're not quite done yet. If you notice, I have two things that are the same. I got x plus 3 in both pieces. When I factored out a GCF from both halves, it ended up with x plus 3. This is exactly what I want, okay? These are the same, which is exactly what I want. Because I can now factor out that x plus 3 from both of these big pieces right here, okay? If that doesn't make a ton of sense, I'll show you where you end up. Once you get your repeated factor, in this case it's x plus 3, my final answer is going to be x plus 3, the repeated factor, times the two greatest common factors that I pulled out put together. So let me show you what that looks like. I'm going to take the two GCFs that I pulled out, and I'm going to put those together. X squared plus 2. So this is my final answer. The final answer is going to be x plus 3 times x squared plus 2. Okay, and this should work if I multiply these two things together, I get back to where I started, right here. So let's just check it real quick to see if that works, because remember, we're just going backwards. We're going from this to two things being multiplied together. So let's see if it worked. I'm going to multiply this out. X times x squared, that's x cubed. X times 2, that's plus 2x. Okay. 3 times x squared, that's plus 3x squared. And 3 times 2 is plus 6. I can rewrite this in standard form, so I'm just going to switch these two. X cubed plus 3x squared plus 2x plus 6. And that is exactly what I started with at the beginning. So it works. My answer up here did the trick. That is my final answer. Okay? Let me give you one more example, this time in a little bit, with a little bit more clear steps, and then that'll do it for this video. This example is bad, so I crossed it out. I'm going to do number 6 down here. So again, when I start, I break it up into two groups. And I look at my first group, and I ask, what can I factor out of that? What's a GCF? Well, these both have x squared, at least x squared, so I know I'm going to be able to factor that out. Is there a number that I could take out of both of them? Well, yes. 3 goes into 15 and 21. That's the biggest number that goes into both. So I know I'm going to factor a 3x squared out of my first piece. 15x cubed divided by 3x squared is going to be 5x. 21x squared divided by 3x squared is going to be plus 7. Okay, so I'm done with my first one. Now I'm going to focus my attention on my second two terms and say, is there a GCF I can pull out of that? But remember, up here, the trick was that when I factored something out, I ended up with a repeated factor. I ended up with whatever is left after I pull out a GCF being being same on both sides. So that means that after I factor something out of this, I want it to match 5x plus 7. Okay, I'm trying to get this to match 5x plus 7 by pulling out a GCF. So let's just think about that for a minute. Both of these things are negative, but both of these things are positive. So that means I'm going to have to factor a negative out of this in order to make them positive. So I know whatever I pull out of this needs to be negative. Okay, now let's just think about a GCF that I could pull out. I can't take out an x because negative 14 doesn't have an x. 2 goes into both of those numbers. And I believe that that's the biggest one that I can do. Okay, so let's take out a negative 2. So I'm dividing both of these things by -2. Negative 10x divided by -2, it's going to switch it to become a positive. It's going to be 5x. Negative 14 divided by -2 is plus 7. And look, they are in fact the same, which is exactly what I want, because now I can just write my final answer. It's going to be the repeated factor 5x plus 7 times the two GCFs that I pulled out, put together. So 3x squared minus 2. For sake of time, I'm not going to multiply this one out to show us that it worked, but this is how you do factor by grouping. We break it into two pieces. We factor a GCF out of the first half, and then we factor a GCF out of the second half. And in doing so, we make a repeated factor. Okay, that's the big key. We need this piece to match this piece. If they don't match, we must not have factored out the correct thing. Okay. So hopefully that made sense. If you have questions, feel free to reach out to me. Thanks, guys.